Hey, LeetCode fam, welcome back. And now let's solve the question 1091. Shortest path in binary matrix. So what it is? You are given an n by n grid which is consisting only of binary numbers, and what you have to do is to find the shortest path from the first node or the first part to the end or the last part, rather than part first index to the last index. And yeah, what algorithm you might use? Think. And yeah, if you said DFS, then you're absolutely wrong. Come on. Just because you know DFS does not mean that you'll use DFS everywhere. This is actually a breadth first search question, or BFS. And if you think of DFS for everything, then I recommend you to go and check out what DFS is, what BFS is, and how they differ from each other. And yes, for BFS, which is similar to level order traversal. Yeah, I know. Boogeyman is coming back. Level order traversal. You use a DQ. So what you do is, and yeah, you have to read the problem statement carefully. Yeah, and yes, all adjacent cells are connected, so it is not just going from left to right or left to down, but you can go diagonally also. Yeah, that is important. And now, yeah, let's proceed. So how you will do that? First, to add the initial node to our top of our queue, pop that node, check for all its neighbors, and if any one of the neighbors becomes equal to the n minus 1 comma n minus 1 or the end of the grid, then you have obviously reached your answer, and you can return the count or the path or what you have taken, or else iteratively go on doing the breadth for first search. Remember, BFS, not DFS. Yeah, you have to iteratively do BFS on each of the neighbors. And yes, the question is pretty straightforward. And now first, let's get the edge cases out of our sight. So what are some possible edge cases? If the initial node itself is 1, then you will never be able to reach the end of the grid. And yeah, in that case, you have to return minus 1. Yes, they are given. If there is no path, then return minus 1. And if the end of the grid itself is minus 1, again, we will never be able to reach the end of the grid. So again, you will return minus 1. So first, yes, let's get that out of the way. So if is equal to 1, or yeah, in Python, what you can do is to refer to the last index, you can directly use minus 1 rather than using length of the grid at the position 0. I think it is n by n, no? Yes. So rather than using length of the grid and length of the grid, you can directly use it as minus 1 and minus 1. And it will obviously refer to the last index. If both are equal to, if one of them is equal to 1, then you will never be able to reach the end of the grid. And now, start it. Start it. Start the level order traversal. No, I'm just kidding. Start the BFS. So what you'll, so read to the question once again. See, you have to start from the top left or 0 comma 0. So from where you'll start? You'll start from 0 and 0. And when you're standing on the start node itself, the distance traveled is actually 1. And yeah, while q exists, what you'll do? Again, this is pretty straightforward. X comma y, and yes, and if you did this, you are absolutely wrong again. You also have the distance traveled. Yes, you pop out the distance, the x coordinate and the y coordinate from the end of the queue. And if at any chance, if x becomes equal to n minus 1 and y becomes equal to, let's define n rather than writing length of the grid minus 1 every time. Yes, if x becomes equal to n minus 1 and y becomes equal to n minus 1, then you can return the distance traveled. And in Python, again, what you can do is make your lives easier by doing like this. Python supports multiple comparisons in a single statement like this. Yes, or else what you have to do? First, define the neighboring nodes, like how you can travel. So, direction, D-I-R-E-C-T-I-O-N-S, yes, good spelling. Direction, so first, how we can go? We can go to left, right, up, down. Let me tell in terms of cardinal direction. So, we can go north, east, southwest. Northeast, southwest, and then the other two directions. Northwest and southeast. Yeah, you can go in these 8 directions. So yes, let me just write those directions in the form of coordinates. So what it is, you can go 0, 1 or right, and then you can go 1, 0 or down, and then you can go 0, -1, which is left, and then you can go how 0, -1, -1, 0. Yeah, -1, 0 is left, and 0, -1 is actually up. And then yeah, let me just write the other 4 directions: northeast, southwest, southeast, and northwest. And what is left? -1, 1 and -1 is left. Is it proper? Yes, these are all the 4. These are all the 8 cardinal distances which you can go through, and don't get shocked by hearing the word cardinal. Cardinal just means north, south, east, west. And yes, now for, and since you already use x comma y, fx comma fy in your STINCS for, yeah, this is directly unpacking the values and calculate dx and dy. Dx and dy refers to the next node which can be traveled. So what it will be, it is equal to x plus f of x and y plus f of y. Yes, and now check for inbounds. I hope you understood what that means. If inbounds meaning if you are in this node, you can't directly go right side because it will go out of bounds. So if 0 is less than or equal to dx is less than or equal to n minus 1, and 0 is less than or equal to dy, which is less than or equal to n minus 1, that means you are still in bounds. Then what you can do, you can append that specific neighbor to the queue, dx and dy. After the appending dx and dy, what do you notice? From this node you actually travel to this node, so you have to increment distances by 1. And if you think yes, your work is done, you're absolutely wrong. Why? Because if there is a 1 over here, you can't travel to that node. So, and at the position dx, at the position dy, yeah, this will never go out of bounds because those are already checked over here. And if it is equal to 0, only then you can continue. And after going to that node, it is better to not visit the same node again and again, or else you will be stuck in an infinite loop. So the best thing to do is to set the currently visited node as 1 so that you will never be able to visit it again. So yeah, just set it to 1. That means you will never be able to visit it. And after the end of the queue also, if you are never able to visit, if it does not return over here, that means that there was no clear path from the start node to the end node. So return -1 as per the problem statement. Yeah, just test it once. It is q dot pop left, not q equals to pop left. And again, have patience, don't rush to everything. And I call directions over here and I call distances over here. Let me make this directions. Yes, directions, and it is distance, not distances. And yes, what you notice is that all the given test cases passed. And now yes, let's modify the example test case 2. So that how we'll modify that? Yeah, let's make this as 1 test case 2, and let's make this as 1 so that yeah, you can only travel till here but you'll never be able to reach the bottommost index. Let's run it once to check if you get -1, and lo and behold you got -1. So yes, let us submit the code once, and if it submits then we can celebrate. And yes, it submits, and yeah, it's like super efficient, mainly because rather than going depth first and searching for all the nodes. You are just searching the neighboring nodes. So yes, please be clear of what is DFS and BFS, and don't directly jump into depth first search always. Check what is required to solve the problem, which algorithm you have to come up with, and then solve it. And so yes, thank you for watching. See you next time, and grind more DSA. You can do it.